Afternoon, students. Everybody can hear me?
Yes,
Students
sir.
can hear me? All right, good. All right, so basically finishing off with statistics. So we're gonna practice today, and I think we're gonna practice on Wednesday as well. But I also want to take the time to do kind of a summary of what we have done so far. All right, just to highlight some of the similarities and the differences in the methods that you use to calculate the various statistical averages and measures of spread, and to highlight the fact that it depends on the type of data that you're analyzing, or not the type of data, but whether the data is raw data, group data, or ungrouped data, the way the data is presented. All right, so I'm going to start out that way. And then maybe I'm just going to do one question, group data. And for that one question with group data, we'll basically do everything that can be done with group data. We'll do mean, mode, median, interquartile range, semi-interquartile range, and maybe even ask some other stuff. Just one example of everything. I'm going to start out with the comparison. I'm going to start out that way. So I'm going to write on the screen and compare everything that we have learned based on the statistics that we're analyzing. All right, so let me come off camera, and I'm going to use a full screen for it. All right, so let's go. Okay. All right, everybody can see the screen, right? I'm using the full screen.
Yes, sir.
All right, good. Okay. So I'm going to do it in the form of a table. All right. So it's like you have the statistics over here. Have the statistics or the statistical average. Let's try it, averages and spread over here. I'm sort of summarizing everything that we have done, right? There was statistical averages and measure of spread. And then now, as we say now, it depends on the type of data. So you might have raw data, or you might have ungrouped data. I might have group data. So let me shift this over a bit. All right, shift this over a bit. And also shift this over a bit. And then we're going to put another line for group data over here. Grouped data. And I'm building it from scratch. You have ungrouped data. And you also have raw data. All right. We're kind of trying to fill out that table. All right, so ready now. So remember, when do you have raw data? Raw data is when you have a small number of values, small number of observations, right? A small number of observations that can be analyzed in the raw state. Small number of values, let's say values. All right, small number of values, example 8, example 8 to maybe 12 values, for example. Ungrouped data is when you have a small number of values but occur in high frequency. So the frequency is high. The small number of values, Small number of values with high frequency. With high frequency. Occurring in a high frequency. Because occurring in a high frequency, you want to still put them in a table. Okay, you can list out when it's just 8 values. You can just list all the 8 values side by side in ascending order. Right? But when is a small number of values, but they're occurring high frequency, still gonna be too much. I might have like 50 values, right? 50 values, but it's just each of them. So it's like you have 4, it's like you have 4, 5, 6, and 7. But occurring high frequency, you might have 10 of this, 20 of this, might have 11 of this, 13 of this. That's the frequency. It's too much to list them. So you have 4 10s, you have 25s, you have, and so on. So this you don't want to list these out. It's too much. And you use group data when you have a large number of different values occurring in high frequency, a large number of different values with high frequency. With high frequency. So you need to group the data. All right? So that is when you use those. So let's put these as, let's say when. When do we use them? Use raw data when you have this. Use ungrouped data when you have that. Use group data when you have that. Trying to summarize what we did. All right? So I'm gonna put a line here. The first thing that we did. Now, if we want to calculate mean, for the raw data, what do we do? Somebody can tell me? We're revising. What do we do when his data is raw? Want to calculate mean? Want to calculate mean? It becomes the sum of the values, sum of x, divided by the number of values. Simple as that. Add up the values and divide by the number of values. That's how we calculate mean when the data is raw. Simple as that. When the data is raw. When you have a group frequency distribution, remember the values are listed, you have to do what we call a sum column. You have to do a sum column. So we'll do a sum column. Should be doing this in red. Should be doing this in red. All right. On this stuff. So firstly, you have to do a sum column when the data is like that, right? When the data is ungrouped, you do a sum column. You do a sum column. And the sum column is a f times x. You do a sum column, and the sum column is f times x. Do a sum column, which is f times x. Frequency times the scores. And then now the mean is going to be the sum of the sum column. Sum of the sum. This means sum of the values in the sum column divided by the number of values, which then is the sum of f, which is this is the number of values. Sum of f is the number of values. That's how we calculate the mean when the data is ungrouped. So when the data is grouped, somebody can tell me what do we do to calculate mean when the data is grouped? When the data is grouped, what do we do to calculate the mean? And firstly, is this an calculated mean or an estimated mean? Can somebody tell me?
So it's estimated.
All right, so when the data is grouped, the mean is estimated. Almost everything is estimated. Okay, I'm just write estimated here. So let's write all estimated, because when the data is grouped, basically all is estimated, all estimated. Everything you do is estimated. Estimated. Everything you do is estimated. Okay, you don't know the actual data. But what do we do to calculate the mean when the data is grouped? What do we have to do? Somebody tell me. When the data is grouped, you basically convert it to an ungrouped data by doing a midpoint column. You do a midpoint column. Do a midpoint column. Midpoint column. You have to do a midpoint column. And you call the midpoint column X. Do a midpoint column and you call it X. All right, you do a midpoint column. You do a midpoint column and you call it X. All right, do a midpoint column. And you're going to call that midpoint column X. And when you do that midpoint column, you call it X. Then you also have to do an FX column, a sum column. Then you do a sum column as well, and you call that FX. And use about the same formula now. We have to do a sum, you have to do a midpoint column first to get the X values. You can't use the group, all the group values, you know. So you use the midpoint of the group. And that is why you're estimating when the data is grouped. You're estimating the mean. And then in that case, now the mean again will be equal to the sum of F times X divided by the sum of F. Sum of F is N. They can say the sum of F times X divided by the number of values. When the data is grouped, you have to convert it to an ungrouped data. Basically, first you have to get your X values. The X values that you use are the midpoint values. And we say that this is not the true mean because you don't know the actual data. We said it in the class. It is not the true mean because you don't know if what you use as a midpoint value, if all the values, you know that all the values in a group are not equal to the midpoint value, but that's what you assumed in doing the calculation. All right, so that is that. But can you recall that? Remember that? Did the test today?
Yes, sir.
All right, good. Then we come to mode. Come to mode next. How do we find the mode when the data is raw? What is the mode when the data is raw? When it's raw data, what is the mode? Come on, guys, man, it's easy. What is the mode when the data is raw? You know, some now move from this until somebody answer. What is the mode?
Sir, the one with the most frequency.
The one that occurred the most frequently. Most frequently occurring observation, or the most frequent observation. That's it. The one that occurs the most when the data is raw, so it's the most frequent observation. Right? Most frequent observation, most frequent value. Keep it simple as the most frequent value is the mode when the data is raw. Simple as that. When the data is ungrouped and in a table, and by that ungrouped data, you have the values over here and you have the frequency over here. And you have the values down here listed, and you have the frequency down here. How can we know the mode when the data is in a group ungrouped table? What's the frequency? What's the mode? Somebody tell me what's the mode? And the data is ungrouped. Data. Anybody? It's the data with the highest frequency, the data that corresponds to the highest frequency. Or the score or the value that corresponds to the highest frequency. That's right, the score with the highest frequency. This means frequency. Or the most frequently, score that corresponds to the highest frequency. So look in the frequency column, for the largest value in the frequency column, and the score that corresponds to that is the mode when the data is ungrouped. When the data is grouped now, how do we get the mode? How do we get the mode when the data is grouped? First, where is the mode located when the data is grouped? Where is it located? Where is the mode located when the data is grouped? It's located in the modal class. First, that's the first thing. Located, the data, the mode is located in the modal class. And what is the modal class? What is the modal class?
So the one
frequency.
The one with the highest frequency. Modal class is the one with highest frequency. But how do we actually now calculate the mode when the data is grouped? What do we have to do to find the mode when the data is grouped? We did the test today. We have to draw a histogram. To draw a histogram and construct the modal, I call it the modal diagonals. You can remember the modal diagonal. So basically, you go like this. You draw the histogram. You have the bars like this. You have another bar up here, for example. That's a histogram. There's a frequency up here. The frequency up here. And you have the scores down here. And the data. They construct the modal diagonal by going like this. Right, you draw a diagonal from this corner down to this corner. Draw a diagonal from this corner up to here. And then you read this value down, put it in blue, or put it in black. When you read this value at the intersection down here, the value that it corresponds down there is the mode. That is the mode value. That's how you get the mode when the data is grouped. You have to draw the histogram and do that diagonal thing. And the modal class is one with the highest frequency corresponding to the tallest bar. So this bar represents the modal class. Right? This is a modal class. This bar is a modal class. This bar is the modal class. Modal class interval. That's the modal class. All right. I'm trying for you to remember these things. All right. So that is mode. You see, what you do depends on the data that you have. The method is different. Right, so that is mode. Let's come to median now. Median. Let's draw a line across here. So we'll talk about how to find the median. Median. In fact, yeah, median. Let's do median.
So the essential number, sir, what's it?
Huh?
Sir, I
And
was
the
saying,
data, and the data is raw. How do we find the median?
oh,
Come on, raw data reach. You're still doing the raw, then we're going to ungroup, then we're going to group. But tell me where you find the median when the data is raw first. Still
So
at
the one,
raw data. Go ahead.
so the one that's in the middle when the data is ordered in ascending order.
That's correct. Right? So it's the middle data, middle value, the middle value of an ascending, can be descending to, but tend to go for ascending, an ascending set of data. It's the middle value of an ascending set of data. What happens if the data is even? If you have an even number of data, what happens? To find the median, what you have to do? The data is even, like if you have 8 values, what do you have to do? If the data is even, like if you have 8 values, 1, 2, 3,
Sir,
4.
add the two.
Huh?
Sir, add the two numbers in the middle, sir, and then divide them by 2.
So you take the average of the 2 middle values.
Yes, sir.
So if even number of data, or if n is even, n meaning the number of data. If n is even, then the median is the average of the 2 middle values. All right? Are you good with that? Are you okay
Yes,
with that?
sir.
Yes,
All right.
sir.
But you know, when the data is ungrouped, how do we find the median? How do we find the median when the data is ungrouped? What do we have to do? When the data is ungrouped, what do you have to do? You don't remember. Cannot do statistics unless you know these things, you know, guys. You cannot do the question. Somebody like mic is open. You want to tell me? You cannot do the question unless you know these things.
Sir,
Like people think
the group data you look for, sir, or on?
ungroup, man. Listen, the order is raw, ungroup, then group. We finish with the raw, so we're doing ungroup now. Same order all the time. Raw, same way I'm teach topic. Raw, ungrouped, group. So tell me now, how do you find the median when the data is ungrouped and in a table? How do you find the median? What do you do to find the median value? That is statistics come on every exam paper, you know, guys. Every exam paper have a statistics question. And a lot of people come to class and say they learn statistics already and know it. Because they believe statistics is about finding mean, mode, and median for raw data alone that they learn in prep and primary school. It's far more than that. Right? It's far more than that. And you have to know these things. You have to know the methods and the approach that you use for everything. You have to know what you do based on what you have. When the data is ungrouped in a table, right? You have to go for the position of the median. That's the first thing. The position of the median, the position of Q2, the median is Q2, equals half of the n plus 1, is half of the n plus 1 term. That's where it is located. That's the first thing. half of the n plus 1 term. And then how you find that half of n plus 1 term? You have to do a cumulative frequency column. You have to add up the frequencies that when you get that value here, you know where in the cumulative frequency column that value is located, and you read the value across in the data column. You have to do the first thing. You have to know the position of the Q2 is half of the n plus 1 term. And then when you get that value, because the data now you put in a cumulative frequency column, then you can search for when you find that value. So suppose this value work out, for example, to the 20th term. So saying Q2 is the 20th term. In the cumulative frequency column, you can find the 20th term and you go across and match back the data, what the data is in the data column, which usually is the first column, the data column, the scores column. All right. All of this thing I did as examples, but you know, put in the work, guys. All right. So when the data is grouped now, how do you find the median? What do you have to do to find the median when the data is grouped? What do you do? What do you do when the data is grouped to find the median? Nobody can tell me when the data is grouped and I want to find the median, what do you have to do? Anybody gonna tell me?
Sure.
Yeah.
Sure. So I could change it?
Yeah, man. Go ahead.
So for the median of group data, say you would have the middle quartile, say I think it would be say what's it say?
Yes, it is the middle quartile, but how do you find it?
Would it be Q2 equal half NTH, sir?
Come again?
Sir, I was saying would it be Q2 equal half NTH term, sir?
Q2 equal a half of the nth term, yes? And then what? Now the Q2 equals, you know, the Q2 term, the position of Q2 is half of the nth term. And then what you have to do? To find it, what you have to do?
Sir, you can use the Ogive graph, sir.
Exactly. When the data is grouped and you want to find the median, you have to draw the cumulative frequency curve. You have to draw the Ogive. You have to do a cumulative frequency column and everything and draw the cumulative frequency curve, which is also called the Ogive. And then the position of Q2 is half of the number of terms. That becomes the position of Q2. So how you do it? So like you have a curve like this. So you have a y-axis, you have an x-axis. And let's say when you draw the curve goes like this. Then this is the position of Q of it right here, half n. So you have n is the total corresponding up here. Half n is the position of Q2, half n. You come across and you read down, the value down here is Q2. Not half, you know, half n. Half n. This is half of n. And that is Q2. Let's say I find Q2. So you have to draw the Ogive curve, find Q2. All right. Let's continue. I was really expecting more cooperation from the class today. You know? The next thing is the interquartile range and the semi-interquartile range. We're talking about how do we find the interquartile range and the semi-interquartile range. To find all of these, you have to find the quartiles. So in other words, how do you find the quartiles? When you find the quartiles, the interquartile range is Q3 minus Q1. But how do you find them? Q3 and Q1. And the semi-interquartile range is the interquartile range that you get from this divided by 2. Semi means half. When data is raw, how do we find it? How do we find those quartiles?
Sir, when it's raw, sir. Sir, when you have the raw data, sir, it would be largest value, sir, minus the smallest value, sir.
Oh, but the largest value minus the smallest value?
I mean data value, sir.
No, man, so like you're talking about range. Asked for interquartile range. Interquartile range is the difference between the two quartiles. These in two quartiles. How do you find them? How do you find Q3? How do you find Q1? So you can subtract them and the data is raw. What do you have to do?
So first we'd have to identify the bottom and top half.
Beautiful. And after you identify the top, bottom, and top half, what do you do?
Sir,
What do you do after? Go ahead.
no, sir, I was saying, as you said, to find the quartile, sir, that's the first thing. And the second thing, sir, is you would say that Q1 is the middle of the bottom half, sir, of the quartile. I mean, the data, sir.
They're saying Q1 is the middle of the bottom half and Q3 is the bottom of the top half.
Yes, sir.
So what separates the bottom half and the top half? What separates them?
So the median.
The median, Q2. Exactly. So if you have the data, you divide it using Q2 into a bottom half and a top half. And then Q1 is the middle of the bottom half. That's Q1. And Q3 is the middle of the top half. So you divide it first with the median, and then you divide the top half with Q3. And then that's how you calculate them, and then so you can find that. That's when the data is raw data. All right? When the data is raw. When the data is ungrouped, how do you find the interquartile range? How do you find the quartiles? How do you find the quartiles when the data is ungrouped over here? What do you do? The position. Yeah, go ahead.
So you would use the fractions plus the number of values and add 1.
All right. I think you're trying to say. Position of Q1 is a quarter of the n plus 1 term. That's what you're trying to say, right?
Yes, sir.
And the position of Q3, this one is Q1, is 3/4 of the n plus 1 term. And then what you do? You have to do the same like how you find the median up here. You do cumulative column and find them, right? So you're gonna do a cumulative frequency column. You can find those values. All right, so when the data is grouped over here now, what do we do to find the median? The interquartile range? Q1 and Q3. So we can subtract them. What do you do? Anybody?
Sir, could you repeat what you asked?
When I'm ready to find the interquartile range, I have to find the quartiles. How do I do it when the data is grouped? Over here is for the group. The last column is for the data is grouped. How do I do it when the data is grouped? How do I find the quartiles when the data is grouped?
You would go to the middle
Middle of what?
of the data.
When the
middle
data is grouped, they want to find the quartiles are the same thing as how you don't find the median. Same thing, right? You have to go and draw a cumulative frequency curve again. That's what you have to do. Use a cumulative frequency curve, the Ogive curve. And this time now, you don't want the median. You don't want the median. So you don't want the median this time. Oh, so you don't want the median. Right? You don't want the median. You don't want the median. What did I do? Erase the curve? All right, I don't want to erase the curve. Let me erase this. Man, keep erasing the thing. You don't want the median. What you want is the interquartile range. You need Q1 and Q3. So you have to come down here and find a quarter n. That's the position of Q3. Come across on the graph and read it down. That's Q1. And you have to find 3/4 n. 3/4 of n. Come across on the graph and read it down. That is Q3. And you subtract them and you have the interquartile range. So if you want to find quartiles from group data, you have to do a cumulative frequency curve. You have to do a cumulative frequency curve. All right. Hope you can remember this from this exercise. Go back and watch over the video. I remember these good minute details that we're doing here. Because a lot of people believe that they know this topic and they don't. And they take it for granted. All right. Everything important. All right. So the next one now is range. Range. How do we find the range when the data is raw? Or what you say for raw data?
Sure.
The data is raw.
Sir,
Yes.
sir, I had a question, sir, for a while ago, sir, when I was saying data set for the raw data a while ago, sir, when I was mixing up with IQ and SIQ, sir.
You have a question, you say?
No, sir, it's not a question, sir, but I was saying when you were doing the IQ and SIQ, sir, I accidentally mixed it up and said what I would find for the range of raw data, sir.
Oh, all right. But you understand, you know the right thing, no, right?
Yes, sir, yes, sir.
All right. So how do I find the range when the data is raw? First column is for raw data. How do I find the range from raw data?
Sir, the largest value subtracted from the smallest value.
I subtract the smallest value. So largest minus smallest value. Largest value or observation minus smallest value. Good. That's when the data is raw. All right. What do we do when the data is ungrouped over here? How do we find the range? How do we find the range when the data is ungrouped? Don't remember. You guys don't look over anything from class. We do the class and just go home and look over nothing, and you all have videos to look at. It's the largest upper boundary. Largest upper boundary. I explained it in the class. It's what's called largest upper BV. Largest upper boundary value. That's a 0.5 value. Minus the smallest lower boundary value. And do the same thing for when the data is ungrouped. Same method they use. I can copy this over here. It's the same method. All right. So what have you looked at? I looked at mean, mode, median, range, interquartile range, semi-interquartile range. What are some other stuff to consider? Those are the main things. All right, those are the main things. So I want you to look back, watch over this slide, watch over this this part of the class, and get the details of how you do what. And it's time for you to do it. All right, depending on the type of data that you have, the method that you use is different. The method that you use is different. All right, let's talk about some statistical diagrams a bit now. Let's talk about some statistical diagrams. First one is bar chart. When do we draw a bar chart? When do we draw a bar chart? What kind of data we use a bar chart to represent? There are two types of data. There's continuous data and discrete data.
So it's for discrete data, sir.
You use bar chart for discrete data only.
Oh, sir.
Right? Huh?
Sir, counting, sir.
Yeah, counting data. Discrete data is counting data. Hold on a second there. Hold on a second there. All right, cool. All right, guys. So use a bar chart mainly for discrete data. Which is counting data, data obtained by count. All right. That's when you can draw a bar chart. Remember, the bars are evenly spaced and they are separate. All right. Bars are separate, evenly spaced, which are the same width. And you have the frequency up here. And these are usually unrelated values. The values here are usually unrelated. Like, for example, you can have bus, number of buses used to do something, number of cars, and number of bikes to do something, right? Usually unrelated. When do we draw a histogram? Histogram. Tell me about a histogram.
Sir, we use it, sir, for continuous. Sir, we use for continuous data, sir, which is measurements.
Or ungrouped data, sir.
Yeah, but it can also be used for group data. You know? Histogram can be used for group data and also ungrouped data. but it's mostly used for measurement data, because measurement, the data that you get when you measure, and the data that you use when you measure depends on the level of accuracy that you want. And what usually happens is that when the data is measured, it goes from one group to the next seamlessly, such that there is always a common boundary between the groups. All right, there's a common boundary between the groups. So, for example, one set of data might be from 2 to less than or equal to x less than, say, 5 point, not 2, so 2.5 less than 5.5. That is one set of data. The next set of data start back at the same place, 5.5. The next set of data starts at 5.5. X is greater than that, but this now is going to be less than 8.5. All right, so these two are the same boundary. So where this set ended at the 5.5, the other one started at the 5.5. And that's why you have to draw the bars of histogram side by side so that they both share the same boundary. Each group of a histogram share the same boundary. Or the adjacent groups of a histogram share the same boundary. So these are histogram mainly for continuous data. And continuous data is when you have to measure something, right? Measurement data, you have to measure something. An important thing to remember about a histogram is that the bars of the histogram are joined side by side at the boundary values. So the first bar here and the second bar is right, are joined into it. Might have another one there, another one down here. And these values, this is a frequency. These are your values. Usually some measurement value. But the important thing is that these are at boundary values. That's a boundary value. That's another boundary value. That's another boundary value. That's a boundary value. And starting out with this boundary value. So the bars join each other at boundary values of the groups that they represent. All right. So that's how you draw a histogram. Next one is pie chart. When do we draw a pie chart? When do we draw a pie chart? What's a pie chart used to show mainly?
How a quantity is divided into parts.
Or you know what?
When a quantity is divided into parts.
Right. You need to divide. It shows our whole is divided into parts. This is used to show how a whole quantity is divided. You're correct. And it is divided according to the fraction of 360 of the total, right? So a segment, a sector should say, a sector of it, sector angle is calculated by the score divided by the total score multiplied by 360 degrees. So the individual score for the sector, right, for the quantity or for what it represented, fraction or the piece, score, individual score divided by the total score multiplied by 360. So that gives you the sector angle for a score. Sector angle for a score, or for an observation. All right, that's how we calculate the angles. Pie chart. Next one was line graph. What's the line graph used for? I mean, what is it used to show?
So trends.
It's used to show upward and downward trends. Yes. Upward and downward trends. And what it does, what can you do with those trends? When you know the upward and downward trends, what you do with them? What information you can get from it? What can you do with it as well? The line graph. You can make projections. You can project what's gonna happen next, in some kind of a way. But how do we do it graphically? How do we project? We have points in a graph. So let's say we have some points. And the points are here, there, 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 and there. Instead of those are the points, so that our line graph is like this, that. Let's put this one down here instead. That and then that. So that is our line graph, our point here as well. That's our line graph. How can we project to the next period? And line graph is usually upward and downward trend over time. Shows upward and downward trend over time. Let's read that in. It's usually over time. Over time. It's usually over time. So this is usually a time axis, so that the years, hours, days, months. This is usually a time axis. Let's say we end right here so far, and we want to know what's going to happen in the next period. So these are the periods I want to predict what's going to happen over here, the next period. What can we do? Want to know what's going to happen here. Want to project what's going to happen right here. You get to this time. What can we do? Where that time would be represented by this line up here. What can we do, guys, to project what's going to happen next?
So you look at the overall trend.
Did it in the class. We did it in the class. We did it in the class. You draw a straight line from the beginning to the end, like so. And then you extend it to the next period. Extend it to the next period. And then you can read off that extension where it intersects there. Read it off over here. This will be the next amount or the next value. And what do we do when we extend that line? What does this line represent? What does this line represent? We did all of this in the class, so nobody can remember these things. But what does this line represent? This line, this blue line that I draw from the beginning to the end. What does it represent? It represents the average of the changes. The average changes, averaging the change of values. Averaging the average of the changes in the value or in the scores. And so you extend that average change for the next period. That's what we do here. Extend that average change to the next period. That's what we do with a line graph. All right. And then the last one, as you can know, is your cumulative frequency curve. What is this used for? What does it represent? I don't think I've added, I'm not certain if I said it. What does it represent really? What is it trying to do? Cumulative frequency curve. What does it show? Yeah, what does it show? I said it in the class. I said it. What does it show? What does the cumulative frequency curve show? And what it shows is based on the information that you used to draw it. What does it show? It shows how many observations, or how many scores, shows how many scores are less than and sometimes it can be less than or equal to less than. How many scores are less than, or it can be less than or equal to any given value or score. So if you give a score, it can tell you how many observations are less than that value. That's why when you draw the cumulative frequency curve, you either put less than scores down here, or you can put less than or equal to scores down here. And then up here is going to be a cumulative frequency. And this is the number of scores. This is the number of values. This is the number of values represented up here. These are the values themselves. And so this represents the number of values. Adding up the frequency. And so frequency is the counting how many things you have, And when you do cumulative frequency, you're adding up how many things you have from lowest to largest. So the ones with the lowest value are the ones down here. Scores with the highest value are the ones up here. All right, same thing over here with the cumulative frequency, which is over here is a number of values. Number of values. Same thing over here. Cumulative frequency is a number of values. When you draw a less than graph, what do you use? You use upper boundary values. That's what UBV means. Right, upper, right, upper. So when you draw with the less than graph, you use upper boundary values. And you plot those upper boundary values versus the cumulative frequency. That's where you draw that graph. If you use this one, then you're going to use the upper limit values. Upper limit values versus cumulative frequency. I could say cumulative frequency versus upper limit values. Right? I put it like this, but this is on the y-axis, right? This value is on the y-axis. You better write it that way around. Usually when you say this versus this, means that the first one is on the y-axis. And I'm going to say, for example, y versus x. It means that the y is on the y-axis, vertical axis, and x is horizontal axis. So I can write them the other way around. So let me make sure and specify. This is on the vertical axis. Vertical axis. Same thing over here. The cumulative frequency is on the vertical axis. Right. So I think that sort of summarizes what we have done so far, and then we can learn how to read and get information from these graphs. All right. I think we left out a frequency polygon, so we can put it here with this. Frequency polygon and histogram sort of go together, and so we can write frequency polygon here. So histograms and frequency polygons. Frequency polygons. And the frequency polygons would be drawn such that you draw frequency polygon, frequency against the midpoint values. So it goes, it's like a line graph with your midpoint values corresponding to the top of your bars. But when you draw a frequency polygon, you must always close it down to 0. You close it down to the value that will come before this one in purple. Close this then down to the value that will come before. Close this one down to the value that will come after. But you carry the frequency down to 0. That is your frequency polygon. Frequency polygon. All right, so I'm gonna show it here. It's the thing with the lines like that. All right. That's the frequency polygon. Set up a line and close it off with the x-axis. That's why it's called a polygon. All right. I think this kind of summarizes it, guys. I want you all to watch over the video and watch these things again. All right. Don't take the statistics topic for granted. A lot of people pay the price for doing that. All right. So, having done that little summary, I'm going to do a question now. So I'm going to use one question. I'm going to use a group data question, and I'm going to do all the things that we do with group data with it. So I want to do everything over here on this side. I will do with group data, so I can illustrate. All right. So let's say I'm going to be using, see what data I'm going to be using. I'm going to be doing everything with that data. Let me bring it up over here. So not necessarily going to answer the questions, we're going to do our own thing with the data, right? That's what I'm going to do. Do our own thing with the data. And put it down here. Let me draw it down here. So I'm going to be using, not too much, I don't want too much. Let's say this one. So these are, let's say this table shows the mark obtained by 100 students in a test, right? So the 100 students, and let's say these are the marks obtained by those 100 students. 100 students, and these are the marks. The data is grouped. Data is grouped, all right? So let me redraw the table over here. I'm going to leave out this column for the time being. Leave out that column for the time being. All right, so let's go. All right, so I have the marks obtained by the students in a test. Marks. And I have 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. Those are the marks obtained in a test. And then we have the frequency. I might have a copy it again to some other stuff. So the frequency here is 15, and then 25, and then 30, and then 22, and then 8. So that's our table with the data in it as present. All right, what are the things I want us to do? All right, let's list them down. What I want to do. I want to do the mean. I want to do the median, the mean, the mode. I want to do the median. I want to do the interquartile range, semi-interquartile range. And I want to do the range. All right, I want to do all of those things. Mean, mode, median, interquartile range, semi-interquartile range. That's what I want to do with this data. Those are the things that they'll mainly ask. And then we can drop in a couple other things. The first one is the mean from group data. All right, so to calculate the mean, formula for the mean, remember, is sum of a sum column divided by the sum of your frequency. That's a formula. So we need to get our fx column, which is a sum column, and we also need to get the x. When the data is group, we're going to use the midpoint value to represent the value. So we need an x column. Note I didn't bother to put on any x that they gave me. I need to put in an x column. So these are the columns I have to put in now. I'm going to copy this down. I might use it again later down. Copy, paste it over here. And the other part. Right, so what do I need? Put what I need in purple, different color, or in blue. I need to put in a midpoint column, which is my x column. So let's add empty. Overlap it. All right, so I'm going to need a midpoint column. And the midpoint, I call it x. And then I'm going to need a sum column. Sum column. And the sum column is f times x. All right, but I can see this. All right, so good. Point. All right, so how do we calculate the midpoint? The midpoint is the average of these two values. It's quicker to do it, but we can also use the boundary value. So that is really 11 over 2, which is 5.5. That's 5.5. And you have to calculate the rest of them. You have to calculate the rest of them. These going up by 10. Those going up by 10. These also going up by 10. So the midpoint values will also go up by 10. Right? The midpoint values will also go up by 10. So next value is going to be 15.5. At 10, we get 20.5. At 20, 25.5. At 10 more, we get 35.5. At 10 more, we get 45.5. So those are midpoint values. So these values now represent these group values. They're assuming that all the values in this group measure 5.5, and there are 15 of them. That's what they assume, which is not necessarily true. They're going to multiply these now. So if you're saying 15 values measured 5.5, you know the sum of these 15 values in terms of marks, in terms of mark obtained, you multiply them to get the total marks obtained by those 15. And so I have to multiply them. All right, so let me multiply them. Somebody work out some of them for me. So the first one, somebody work out the second one in the meantime, and somebody work out the third one, and so on. So the first one is 15 times 5.5. I'm getting 82.5. So 82.5, the first value. Somebody work out this one.
Sir, I got 387.5.
387.5. Next one. That is 765.
Let me get you.
And 781.
Yeah, for the last one, I get 364.
364. All right. And then now the sum of the frequency. This is the sum of the frequency, which is really the number of values, is 100. It's going to add up to 100 because the detail loss is 100. It's 100. All right, let's just double check that. 15 plus 25 plus 30 plus 22 plus 8, yeah, 100. And then we're going to sum this now. This now is the sum of fx, the sum of all the values. Let's put it under here. To add up these now to get the sum of fx. Sum of fx, the sum of the sum.
So let me get 2,380.
2,380.
Yes, sir, for the sum fx.
2,380. All right, that's it. So therefore, the mean down here become equal to this mean becomes 2,380 divided by 100, which is 23.8. Simple as that. That's how we calculate mean when data is grouped. You have to remember to put in a midpoint column, represent the group. The question is now, why is this not the true mean? Why is it only an estimated mean and not the true mean? Somebody tell me. Why is this an estimated mean and not the true mean?
Sir, because we don't know the exact value in the middle because it's group data.
So that better than that. Am I in the middle?
Oh, we can't find the exact wait, the mean or the median, sir?
I'm talking about the mean that we just calculated. Why is it an estimated mean? Why is this mean that we just calculated an estimated mean and not
Sure,
the real mean?
because it's group data, we're not sure what are the exact values.
All right. So because the data is grouped, you don't know the exact value of the data in a group. And what you did, you assumed that all the data in a group measured had the midpoint mark, which is not necessarily true. So for example, in the first group, you're assuming that all 15 students in the first group scored a 5.5 marks, which is not true. Right? It's 100 students to the test, 100 students. So you assume that all 15 students in the first group scored 5.5. So using 5.5 to represent all the students that scored from 1 to 10. But maybe some of them score 1, and some of them score 1.5, and some of them score 9, some of them score 6. But you're here assuming that all of them score 5.5, which is not necessarily true, and almost certain not to be true. All right, so that is why the data is estimated. We estimated that mean. It's an estimated mean. All right. The next thing we want to calculate, and we can maybe do it over here now. Get that screen over here. We're not gonna come back to this question. All right, we're just gonna do some stuff with it. All right, so let's calculate something else again. Now, next thing, now, how do we get the mode? We want the mode. What do we do to get the mode? What do we do to get the mode? Just did it a while ago, When the data is group, how do I get the mode? Just did it a while ago. When the data is grouped, how do we get the mode? First, where is the mode? Where is it located? Where is it?
Sir,
Where would
20
the mode be?
30,
Huh?
21 to 30.
That's the modal class. The mode will be right here. So that is called the modal class. So the modal class is 21 to 30 marks. Right here, the one with the highest frequency. But how do we get the mode now? What do we have to do to get the actual mode or to estimate the mode? We're still estimating. What do we have to do to estimate the mode? The mode value or value. What do we have to do to estimate the mode?
Sir, sum of f times x over the sum of f.
No man, that's median, man. We just do it median a while ago using that. Come on, man. The mode is one of these values. How we gonna get that one? How we gonna find which value it is? Between 21 and 30. What do we do to find the mode? The mode is one of the values inside here. What do we do to estimate the actual mode? Just did it a while
That's the
ago.
highest frequency, sir.
Huh?
Sir, the mode would be the highest frequency, sir.
Look here. Listen. Don't just listen. Listen to what I'm saying. The mode is one of these values. The mode is somewhere in one of the between 21 and 30. Oh, I know. Because the highest frequency is 30. So I know that that's a modal class. Modal class is where the mode is located. I'm saying, knowing that this is a modal class now, how can we estimate an actual value for the mode? Not just a
Sir.
modal class. Go ahead.
So I have to construct a histogram.
We have to do the histogram and do the diagonal thing on the histogram. To find the mode, you have to do the histogram, and then in the modal class, you're gonna do the diagonal thing in the modal class to see, estimate what the actual mode is. So you have to draw a histogram to get the mode. So we have to draw the histogram to get the mode when the data is grouped. All right, you have to, all right, I'm not learning still. You must have to, you have to look over these things, guys. Everything important. Don't assume stuff. Don't assume that this topic is just straightforward and simple. See, these are nuances, these are minute data. A lot of people spend time to try to give you these minute data. So to estimate the mode, you have to draw the histogram. So to find the mode, we have to draw the histogram. Draw histogram. All right, so we're gonna draw a histogram over here now. All right, so in drawing the histogram, what are the important features of drawing a histogram that we must ensure? When we draw a histogram, what is it that we must ensure that when we draw a histogram? Where do the bars of histogram go? Huh?
So the bars are supposed to be touching each other.
And what values are they supposed to be? What values do we use for the bars? What values do we use for the bars of a histogram?
Sir, the boundary values.
The boundary values. We use the boundary values for the bars of a histogram. The boundary values. So the bars touch each other at the boundary values. All right. So I'm going to draw it like right here. Going up to 30. All right. So let's do it right here. All right. So I'm going to go by 10. So it's going up to 50. I'm going to go by 10. I'm going to go 10, 20, 30, 40, 50. 10, 10, 20, 30, 40, 50. These are my marks. And I'm going to put my frequency up here now. Frequency. The frequency go up to a high of 30. Let's go by 5. 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. All right, could have been a little bit taller, but look, no problem. We work with that. All right. Then the values that we're using for the histogram, guys, are the 0.5 values, the Ogive values. So the bar is gonna go. Look at the graph over here. I'm gonna write in what the bar is gonna go. It's gonna go 0.5 to 10.5, then 10.5 to 20.5. Now notice this value and this value is the same. So I can just keep following out the right side to where the Ogive values are. 30.5, 40.5, 50.5. Those are the values where the boundaries will go. I'm going to put in those 0.5 marks for you. I'm going to put them in red. I'm going to put 0.5 right there. And this is 10.5, 20.5, 30.5, 40.5, 50.5. That's where the bar is going. The first bar has a frequency of 15. So it's 15 tall. So come up to 15. The first bar comes up to 15. See there? Comes up to 15. Like that. That's the first bar. What we do sometimes, we put the 15 on top here. The second bar comes right beside the first bar, but it goes up to 25. So this can extend this line, this boundary up to 25 right there. And extend this one, goes up to 25. That's my second bar. That's what I did. I mark all my boundary values where the bar is going to be first. Those are all the 0.5 marks. Do it on graph paper, you'll see them. All right, that's my second bar. And I'm going to put the 25 on top right here. The third bar goes up to 30. I'm going to extend this boundary up to 30 right there. Extend this one as well up to 30. And then join it across there. 30. On graph paper, you'll see it precise. I'm just sketching it now. This is 30. Next one drops down to 22. So 22 is just a little bit above this line. 22 about there, so. All right. I said 20, maybe around there. So I'm gonna put it right here and drop it down to there. $22. And then the last one drops down to 8. This is 10, 8, maybe it's around here, around 8. So I'm gonna drop it down to around here. I'm gonna like that. This one is 8. On graph paper, you see it for sure. That is 8. So that is my histogram. This is my histogram. All right, that's my histogram right there. And then now, show you something with histogram now. I'm gonna put my frequency polygon on the histogram. My frequency polygon, for to show it on this histogram, it would be frequency and midpoint you're using for a frequency polygon, those values. And the midpoint values are in the middle of the bars. So the top of the middle of the bars correspond to those points, 5.5, 15. See, 15.5, 25 is right in the middle of the top of the bar. It means the right just says 5.5, you know. 5.5, the middle of the bar. The middle of this bar is 15.5. So those points would correspond to my frequency polygon. So I can draw the straight line between the points and copy this down first. I'm going to use by the same diagram to do the construction for it. Copy it down. Other part, just copy it and use it again. And this one, just taking the opportunity to show you the frequency polygon for now. All right, we'll come back up on this one. By drawing these with straight lines, I am forming my frequency polygon. Straight line there, straight line there, straight line there, straight line there. And then what you have to do, you have to close it. Remember now, this point will be 45.5. Right here is 45.5. Right here at the middle of the bar is 45.5. And so the next value will be 55.5. So it's like the 10 will be the next after 50 would be 60. So this is 60. But the next midpoint coming after this one, going up by 10, that is not shown in a table, will be 55.5. Right? Right here. Will be 55.5. We don't appear on the table. See, there's no 55.5 on the table. So the frequency of 55.5 is 0. So you close it down to 0 right there. And then at the other end, the value before this is 5.5. Gonna come out negative right here. It's 5.5. The value before that would be a negative value. But here, you can have that too, you know. The next value before this will be negative 10. And so it will be negative 5.5 will be the value here. It will be 10 before this will be negative 5.5. So this will be negative 5.5. That don't appear on the table at all. So like somebody do the test and lose marks, actually. So I gain marks, them get things so wrong, them lose marks. Right? So that would be down a frequency as you close the polygon there. That would be a frequency polygon in purple. That would be a frequency polygon in purple. So if I erase all of this, these lines, I'll be left with your frequency polygon. I'll be left with your frequency polygon. That will be a frequency polygon right there. That will be a frequency polygon, guys. Notice I close the two ends. So the value that is coming after this 55, 45.5, which is the last midpoint value, I put a value after it, which will be 55.5, but the frequency is 0. And since this is going up by 10, the value before 5.5, you have to subtract 10 from it to be negative 5.5. But that is not on the table, so it will have frequency of 0. That will be a frequency polygon right there. But let's get back to the histogram now. So this is my histogram that I drew. Let me take off these points. Don't need these points on it anymore. Let me take them off. I'm trying to get my mode. So this tall bar is my modal class. This tall bar represents my modal class. Modal class. Modal class interval. And I want to estimate the mode. To estimate the mode, what I do, I draw a diagonal from this corner to this corner. Where the next bar is, where the next bar is, corner of the next bar, like this. Then I draw one from this corner to this corner. And look here, the mode is going to be more to this side because this bar beside the modal class is taller than this bar. This bar beside the modal class is taller than this one. So the mode is going to be closer to this taller bar in the modal class. To estimate it, we do these diagonal things. So you're going to draw a diagonal from this corner down to here. You're going to go like so. And you see that if the middle of the bar is right here, this is the middle of the bar. It's that it is to the left. Remember that the middle of the bar is the middle of that modal class bar is 25.5. So we know that right here in the middle is 25.5. Right here, that's marked. Middle of the bar is 25.5. Move this 30 for the time being. This is 25.5. 25.5. But the mode now would be to the left of that, left of the middle, as it's closer to this bar. It's not going to be in the middle, it's more on this side. Right, that would be the mode. That would be the mode. So this value now will be the mode. Estimate of the mode. Mode is approximately equal to something less than 25.5. Let's call it 24. Right, let's call it as 24. Right, 25.5. Let's call it 24. Just for argument's sake. Something like that, guys. Not to scale, but to get the picture. But understand that?
Yes,
That's
sir.
what all right. Next thing now that we want to do, now the median. So we do the mode. We have to draw the histogram to get the mode. Next thing we want to do is we want to get the median. Talk to me now. Ready for the median now. Let's shift this down a bit. What do we do now to get the median, guys? The data is good. Talk to me. What we have to do to get the median? Anybody?
Question?
Huh?
Could you repeat the question?
Do what?
Could you repeat your question, sir?
What do I have to do when the data is grouped if I want to estimate the median from the data, the median when the data is grouped? What do I have to do when the data is grouped to estimate the median? How do I estimate median from grouped data?
You find the interquartile range.
Median, I said. Interquartile range is Q3 minus Q1. I'm trying to find the median, which is Q2. That's what I'm trying to find. When the data is grouped, how do I find it? What do I have to do to get the median? The data is grouped.
So draw Ogive.
Draw the Ogive. Draw the Ogive. Draw the Ogive. Draw the Ogive and look for the half n. Half of the n and read it down here. Exactly. When the data is grouped and you want to find median, you want to find interquartile range, you want to find the quartiles, you have to draw the Ogive. All right? So for this one, I have to draw the Ogive. I get it from the O. In fact, I get all of these from the Ogive. All of these. I get them from the Ogive. Because remember, this is Q3 minus Q1, you know. So these relate to the quartiles. I get these by finding the quartiles. And the quartiles, I get them from the Ogive. Ogive is a cumulative frequency graph. Cumulative frequency curve. That's what the Ogive is. So I have to draw a cumulative frequency curve. All right, so we're going to do it down here now. So that's why I have this table left back here. To draw the cumulative frequency curve now, the approach is different. We don't use midpoint. We don't need no midpoint. We don't need no sum column. We're doing a cumulative frequency curve. What we need is a less than column. All right, I will need a cumulative frequency column. Let me show you something now. I don't ever put in a less than column. I can draw it from what I have right here. All right, let me shift that over. I'm going to put in a cumulative frequency column. Let's put in a cumulative frequency column. Cumulative frequency. So I'm adding up the frequency. That's what I'm doing, adding up the frequency. I'm counting up the frequency as I go. Because, as I said, I'm going to do a less than graph. I'm going to do a less than graph. So, because I'm going to do a less than graph, I am going to be using the upper boundary values. I'm going to be using the 10.5. So here, therefore, I'm putting in less than. It's almost like I'm injecting a less than column here. Less than. Upper boundary value of 10 is 10.5. Upper boundary of 20 is 20.5. 30.5. 40.5. 50.5. All right, let me shift this down a bit for a particular reason. Let me just shift this down a little bit for a particular reason. I'll show you afterwards what the reason is. All right, so I'm working with that. So this is our data. All right. Then I'm going to do my cumulative frequency column. Now the question is, what the cumulative frequency column is basically showing is, for the cumulative frequency curve, is I'm saying how many students got less than 10.5 marks, less than here, less than 10.5 marks, 15 of them. So I start out with 15. And then how many students got less than 20.5? That's what the graph is going to show now. The frequency graph shows how many students got less than these marks, the upper boundary marks. I'm using a less than graph. How many students got less than 20.5 marks? How many? 20.5. All of these marks are less than 20.5. There's all these students, ones who got less than 10.5 and all the ones who also got less than 20.5. So all these students got less than 20.5 marks. That's why it is 15 plus 25. So I have 40 students covered so far out of the 100. 40. So 40 students scored less than 20.5. Shift this column over a little bit to the right. Here. Then I want to know how many students scored less than 30.5 marks. But that's all I can know from the data. I don't know the actual marks stored by the students, but I can know how many students scored less than 30.5. All of these students scored less than 30.5 because these are all the marks that are less than 30.5. And these are all the students. So I add 30 more. So it becomes 40 that I have so far plus 30 more here. So I know that is 70 students. 70 students scored less than 30.5. Then how many students scored less than 40.5? All of these students scored less than 40.5. Those are all the marks less than 40.5, which are all of these students. I have 70 already. I need 22 more. So it's 70 plus 22. So 92 students scored less than 40.5. And then you have 8 more students now for the ones who score less than 50.5. So how many students those score less than 50.5 marks? All of them, because the marks only came up to 50. So all the students scored less than 50.5. So that is the 92 we have so far, plus the 8 more makes 100 students. So I'm going to draw a graph to show how many students score less than any mark. So therefore, I'm going to be drawing a graph of these values against these values. That's what I know. So my graph is going to show me how many students, because these are the number of students. Cumulative frequency is the number of students, 100 students. And these are the marks that they scored less than. Those are the marks that they scored less than. So the graph, I'm going to draw a graph that shows how many students scored less than any mark, any given mark, based on the data that I have. 15 scored less than 10.5 marks, 40 scored less than 20.5, 70 scored less than 30.5. I know that 92 scored less than 40.5. And I know that 100 scored less than 50.5. If I plot a graph with that information, then that graph will be able to show me how many students scored less than any mark that I want. I'm going to copy this graph down again. On this side, I'm going to use the same scale. Just that I'm going to put in cumulative frequency instead on the vertical axis. Copy this down. Start with it. Right, copy it down here. Make it smaller. All right, and then I'm going to take this out, right? I'm going to take out all of this. Take this out. Don't need this. I'm leaving those red marks. Those are already my 0.5 marks, right? Right, then put these in now. So those are already my 0.5 marks. This is 30. So those red marks are my 0.5 marks, right? This is 0.5. This is 10.5, which is a boundary. 20.5, 30.5, 40.5, 50.5. Those marks are my 0.5 marks, the red marks. So that's where my graph will be drawn. But I need cumulative, I don't need frequency up here now, I need cumulative frequency. I need cumulative frequency up on the y-axis. So up here I have cumulative frequency, which really are my students. So you can look at it this way, and it's 100 students, right? So 10, 20, 30, 40, 50, 60. I'm going to go 20, 40, 60, 80, 20, 40, 60, 80. It's kind of too narrow. So let me get these out a little wider. Let's see if we can get this a little wider. So I'm going to go, I need to go up to 100, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Good. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 students. So these are my 100 students. So these are my students up here. These are the marks that they scored in the test. The ones who scored the low marks are the ones down here. And the students who scored the high marks are the ones at the top. That's how the cumulative frequencies graph is going to go. And the graph is going to show me how many students scored less than any mark. And therefore, my horizontal axis is not just going to say marks, it's going to say less than marks. And the graph is going to show me how many students scored less than any mark. And that's all I can know. The reason that is all I can know is because I don't know the actual marks scored by the student. All right. So now I'm plotting these points. I'm plotting these values against each other. Let me use the red. I'm plotting points. Let me use the red. All right. So 10.5 gives a frequency of 15. So 10.5 is right here. Gives a frequency of 15. Let's use the red. 15. So I come up to 15 and zoom it up. 15 is about here. So 10.5, 15. About here. I'm plotting points now. Plotting points. And then 20.5, give me the frequency of 40. So 40 students score less than 20.5. So 20.5, 40. 40 students score less than 20. 40 here. 40 students less score less than 20.5. So I'm putting 40 right here. Then 30.5, 70 students score less than 30.5 marks. 70 students scored less than 30.5 marks. I'm going to put that. 30.5 here, 30.5 marks were scored by 70 students scored less than that. We're talking about right here, that intersection point right there. You can erase these. Then now, the next one is that 92 students scored less than 40.5. So less than 45.5 marks were scored by 92 students. So come up here, and this is my 40.5 marks line. 92, this is 95, so 92 maybe that around here. A little bit higher, around here. I'm talking about around there, so I'm going to use this point, and then erase this, and erase this, and that. All right, let's get it proper. And then now, all the students, all 100 students scored less than 50.5. So less than 50.5, so 50.5, oh, 50.5 here. All 100 students, all 100 students scored less than 50.5. All right, so I'm gonna put it here. Maybe it's a little bit too. Maybe this one needs to be a little bit straighter. So maybe it's around here. This one needs to come down a little bit, right? Oh, there, so. All right, so that's it. Around here. That's my curve. That's my points. Those are my points. All right, so watch me now, students. Somebody pay attention now. Not paying attention before, pay attention now. I'm going to do next is very important. So the graph, if you want, if you use these points, what you tend to do is just draw the graph from here. You cannot just draw that. The graph must always go down on the x-axis. So how do you know down on the x-axis, where does it go? Where it goes on the x-axis? Comes down to the values. Remember, this is 10.5. And this is 20.5. And this is 30.5. So they're going up by 10. So to bring it down on the x-axis, you want the value to come before 10.5. The value to come before 10.5 would be 0.5. So the 0.5 here. Well, 0.5 was not given on the graph. So I'm going to put that in. The value before 10.5, if you're looking at these values, the value before 10.5, put it in blue, would be 0.5. But it was not shown, it was not given in the data. So the value before 10.5 was 0.5. So that has a frequency of 0, cumulative frequency of 0. So you're going to pair these two now on the table. The value before 10.5 will be 0.5, but because it was not given, it has a frequency of 0. In other words, no student scored less than 0.5. So you're going to put that mark right here, and that's where you bring your graph down to the x-axis. You put that point here. You put it down in purple so it stands out. Right at the 0.5 mark, you put a point there. That is 0.5. Bring it down on the x-axis, that's 0.5. The value that will come before 10.5 was 0.5. You bring that down on the x-axis, down to 0. Frequency, cumulative frequency of 0. And then you draw the curve with this point involved, with this point included. So the curve would basically go like this now. Nice, smooth, kind of flat because of how I scale it up. We draw a nice smooth curve through the points. And even on this thing that is not drawn to scale, it still has that characteristic shape that you're supposed to have, the Ogive shape. The frequency curve must kind of have this shape all the time. All right. All right, so before I start answering the question, CXC sometimes will ask you to explain the significance of this point and put it in black. What is the significance of this point? What does this point mean in words? Put this point in your own words. What does it mean? That the cumulative frequency of 0. Remember, these are the students, number of students. This is the number of students. And when the mark is 0.5 on the x-axis, you're coming down on the x-axis. What does that mean? What does this mean? What's the significance of 0.5 on the x-axis? Can anybody tell me? Remember, the graph shows how many students score less than any mark, you know. And right here, the mark is 0.5, and it's on the x-axis where the number of students is 0. So tell me in your own words now what that point means that I've circled. Somebody tell me. Nobody can tell me. It means that no student scored less than 0.5. That's what it means. No student, number of students that score less than 0.5 is 0. The graph shows how many students score less than 0.5. And so at this point, the number of students is 0 and the mark is 0.5. So it means that 0 students score less than 0.5 marks. So you can say it this way: no student scored less than. Let's write the word less than for you. No student scored less than 0.5 marks. Everybody get 0.5 or more. That's what it means. All the students scored 0.5 or more. No student scored less than 0.5 marks based on the data. So far, so good? So far, so good, everybody?
Yes, sir.
All right. Now, we're going to watch over this video. Then if you want to find the median is half of the total frequency. In other words, if these are your 100 students in a line, from the ones who score the low marks down here, see? The ones down here correspond to some low marks, and the ones at the top are the ones that score the high marks, see? The ones at the top are the ones who score the high marks. So the students are in ascending order, from the ones who score the low marks to the ones who score the high marks. So these are the students in ascending order. If there are 100 students there in ascending order in terms of the marks that they scored, and you want to find the median mark, which student of the 100 students would have the median mark approximately? Which student? If there are 100 students there, which student would have the median mark of the 100 students? Which one? The 50th one, the halfway one. See there? The 50th one, that is your half n. That's the half of n. The 50th student. The 50th student would approximately score the halfway mark, the median mark. The student halfway of the data. So this is what we call the position of Q1, 50th one. So this is the position, not Q1, Q2. Position of Q2 is half n, which is 50. Position of Q1 is half n, Q2, I mean. 50, half of 100 is 50. So to find that quartile, you come across on the graph like so. And you read the mark down. You read the mark down like this. And that looks like maybe around 25 marks. I know, more than 25. I see this is 20 and this is 30 now. So 25 would have been about there. So like about 26. So let's say it's 26 marks. So let's say this is Q2. Q2 is 26. Q2 is 26 marks. That's the median. That is the median. Q2 is 26, so the median is 26. Good. If I go back to this and I want to find the interquartile range and the semi-interquartile range, then I need to find the quartiles. So where would the first quartile be? Of these students, which one would be the first quartile student? If there are 100 students, which student is going to be the first quartile student that has the first quartile mark? Which student? This is the median. Shift this down. Nobody can tell me? If there are 100 students, which student is going to have the first quartile mark? Guys,
Sir, could you repeat that?
I'm searching for the Q1, first quartile mark. How do I find the first quartile mark? If there are 100 students in the line, which student in the line is going to have the first quartile mark?
The 25th student.
Good. If I want to find Q1, I have to find the 25th student right here. 1/4. That's 1/4 of n. That's the position of Q1. Not Q1 itself, that's just the position of Q1. It's not Q1 itself. That's the 25th student. That's where it's positioned in the line of students from 1 to 100. So you find his mark by coming across on the graph and reading it down here. That looks like about 17. Let's say that is 17. That is Q1, and let's say that it is 17 marks, for argument's sake. Looks like around 17. And then now I want the upper quartile mark and the third quartile mark. If it's 100 students, then which student in the line of 100 students, arranged in ascending order, would have the third quartile mark? Which one of the students in the line of 100 students? Which one? Which student I'm looking for to find the first, the third quartile mark?
Sir, would it be the 75th student?
75th student right here, because E is now the 3/4 of n student in the line. That's his position. That's the position. That's the position of Q3, not Q3 itself, only the position of it. To find Q3 itself, you have to come across on the graph and read it down to get the mark. That looks like around 32. Let's say that this is 32. Q3. Let's say it's 32 marks. So I know of my quartiles. So from my quartiles, I can now draw my conclusions. The median mark, Q2, is 26 marks. That's the median mark. The interquartile range of the marks is Q3 minus Q1, which is 32 minus 17. Well, that's equal to 15, not it? 15 marks. The interquartile range of the marks is 15 marks. And the semi-interquartile range of the marks is the interquartile range of the marks divided by 2, which is 15 over 2, or 7.5 marks. 7.5 marks. Better go do that.
Yes, sir.
Yes, sir.
All right. Okay. I'm gonna ask something else about the from the graph. But before I do that, let's talk about the range. Let's ask about the range in green. I'm circling in green over here. Because I want to find the range of the data, the range of the marks scored by the student. What is the range? The data was presented like this. Group data. What is the range of the data equal? Simple stuff. When data is group, what is the range? The range is equal to what?
The upper boundary limit subtracted from the lower boundary limit.
Good. It is the not limit, the upper boundary. Don't say limit. Don't use boundary and limit in the same sentence. Boundary is boundary, limit is limit. Don't say boundary limit. Say boundary value. Better say boundary value. Because you have boundary value and you have a limit value. So the limit values are the values as they appear in the table. But the boundary values now are the values between which a value can be taken to fit in the group. So it's the largest upper boundary minus the smallest upper boundary. So it will be the 50.5 minus the 0.5, which will be equal to 50, don't it? You won't go and say 50 minus 1. 50 minus 1 is 49, which will be wrong. So the range of the marks is 50 marks. Let me show you something now, why it is also 50 marks. Because if you look at the histogram, look at the histogram spanned your range of values. You know? See, the last value out here is 50.5 and the first value down here is 0.5. This is 50 wide. That is the range of the data. If you also look at the histogram, the same thing. Right? The histogram ends at 50.5 because that's what the last value that we used, and starts at 0.5. So the range again is from 0.5 all the way over to 50.5. So the range of the data is that. So that kind of explains it as well. But the histogram will always give it the range, because this kind of depends on whether you use boundary values or limit values. All right. All right. So that is that. Now let me put in another question now. What time is it now? Let me see the time. 5:40 something. You guys need to go and watch over this video. You need to go and watch over this video for this class. A lot of material we went through today. That is the thing with statistics. Easy, but it is vast. It's easy, but it is vast. A lot of small pieces it has. And you need to understand and appreciate and recall and remember each piece. Everything important. All right? Everything important. A lot of people cover this topic with too much scant regard for the details. You have to pay attention to the details of it. All right? So another thing I'm going to ask you, I'm going to put in another question. All right? So we did all of these things from the data, and we looked at what we need for each one. So we said for the mean, we had to do a midpoint and an FX. For the mode, we had to go in the modal class, and to estimate the mode, we had to do the histogram. We said the histogram, remember, it goes from boundary value to boundary value. Then when we wanted the median and the interquartile range and the semi-interquartile range, we had to be able to locate those by locating the quartiles. But because we don't know the actual values scored by the students, we can only know how many students scored less than any given value. Then we draw a graph that shows that. The graph that shows how many students scored less than any given mark is a cumulative frequency graph, which is also called the Ogive, a cumulative frequency curve. So draw the cumulative frequency curve. And since there were 100 students in the class, when the cumulative frequency graph sort of simulates putting the students in ascending order. So these are the students in ascending order. The ones who scored the low marks are down here, the ones who scored the high marks are at the top. So that the students are in ascending order. So if you want to find the median mark of the 100 students, and they are now in ascending order, then you need to go and find the 50th student in the line of students and find out the mark of the 50th student. And that's what we did right here. And come across and read the mark down here. I got it at 26. If we want to find the interquartile range of the mark, then we need to find the first quartile mark and the third quartile mark. The first quartile mark corresponds to the 25th student because that is 1/4 of the 100, 25. So find the 25th student down here, and we'll find out his mark by reading it down here. Then you want the upper quartile mark. The upper quartile mark is a mark scored by the 75th student in the line, 3/4 of the 100 students. So here is where that student is positioned, the 75th student. Then we come across on the graph and read his mark down here again. That's what we did. And then we got the three quartiles. The middle one is the median. Q2 is the median. Q3 minus Q1 is the interquartile range. And then the semi-interquartile range is half of that. All right, that's what we did so far. But I want to ask you another question now. Suppose in this test, right? Question said, so the question said something like 20 students passed the test. And I asked for the pass mark. So I asked a question like, what is, there was the estimate, everything is estimate. And when the group, when data is group, estimate the pass mark if only 20 students passed the test. So if only 20 students passed the test, they're asking us to estimate what the pass mark is. So how can we do that, guys, from the cumulative frequency graph? How can we do that? Let me copy back the graph down again and take off some things out. Right? Let me copy. Let me copy it down here. I'm gonna take some things off it. All right, let me copy it down here. That's the beauty about the online thing, you know. And copy this. If I have this on the board in a class, then I've been problems. I couldn't do so many things with it, right? But that's the beauty about the online. You can be using a device and copying and erasing, and it's not a big issue. All right, so this is my graph. I don't want the quartiles anymore. I'm taking them out. Don't want them anymore. All right. All right, so draw a cumulative frequency graph. That is it. The question said, only 20 persons pass the test. Estimate the pass mark. What do you do? Nobody can give me an idea? What do you think? If only 20 persons pass the test, I say estimate the pass mark from this data.
Sir,
What
it
can
would
we do?
be the pass mark or the mark on the 21st person.
Mark that the 21st person got.
Yes, sir.
All right, that's good. Give an explanation for the class.
All right,
Come
because
again. Say it again. If only 20 persons pass the test, come again. Who is to pass it?
wait, you asked if 20 persons passed or failed it.
Only 20 persons pass the test. Say it again.
Oh,
Let me see if I can
only 20 persons passed this.
pass the test. What is the pass mark? If only 20 persons pass the test.
All right. So to find out how many or to find out the pass mark, we would say that because only 20 persons pass the test, we would go to the 80th person, and then we draw a line over to the cumulative frequency curve, and then we'd see where it lands on the, or what's the x-axis for the point where the cumulative
So
frequency.
why go up to the 80th person?
Because it says that only 20 persons passed, and 20 from 100 is 80.
20 from 100 is 80.
Yes,
So you're saying the 80th person passed the test as well.
yes, sir.
All right. All right, listen to the question again. 20 persons pass the test. But you are saying that the 80th person.
No, the
passed
81st person. It'd be the 81st person, yeah.
Good.
The 81st.
Because if you take out, if you have 100 persons who pass the test, and you take out the 80 persons who pass the test, it means that 80 of them failed, don't it? If 20 persons pass the test and they were, but other students must be listening, you know, listen. If you have 100 students and only 20 pass the test, the first you must establish that the 20 who pass the test must be at the top, because the ones at the top are the ones who got the high marks. So if only 20 students pass the test, it must be the 20 at the top up here, the top 20 up here. The top 20 students. The ones at the top are the ones who got the high marks. So remember, to pass the test, you have to score high enough. So it's reason to know, or reasonable to understand that it must be the 20 at the top. But if you think of it this way, if 20 persons pass the test, and you subtract those 20 persons from the ones who passed the test, you're gonna have 80 persons left. So it means that the 80th person also failed, don't it? Don't it?
Yes.
So the first person who passed the test is the 81st person. That's a way to look at it. So the top 20 persons really the 81st to the 100 person, you know, but we tend to just subtract. And so, okay, subtract 20 and you're working with the 80. But really and truly, the 80th person also failed. Because if 20 passed, then 80 failed. So the 80th person is also a person who failed. So the first person who passed the test really is the 81st person. So you really want to start from 81st person. So you come like this, 81, 81. You go to the 81. And 81 to 100 is 20 persons, that you know. If you count 81 inclusive to 100, that's top 20 students, you know, top 20 students. They get the high scores. Pass the test. If you do 80 still, you know, if you come at 80 and you say to the examiner, you have to score more than what the 80th person got to pass the test. Because remember, you know, the graph is going to show you how many, if you go 80, it's going to get, you're going to basically say, you're going to basically be saying that 80 students got less than this mark. So in order for you to pass the test, you have to score more than that mark. You understand me? So you can put it as a pass mark just the same. It's just an estimate. So a student who come to 80 and go across and give them the 80 value, 60 might give it the marks just the same. But in a precise way, you really want to say that the 81st person is the first person who passed the test. Right? So you come across on the graph from 81, come across from 81 like this, and you read that mark down. Right there. That look at about at 36. So let's say that this is 36. Let's say that this corresponds to 36. When you do it on graph paper, you'll know. So this is 36 marks. So you're basically saying, this is basically saying 81 persons scored less than 36 marks, you know. That's what it is really saying, you know. 81 persons scored less than 36 marks. So therefore, in order for you to pass the test, you need to score more than 36 marks. You can look at it that way. And that is why if you come to 80, if you come to 80 and use 80 as your test point instead, and come to 80. That's all right. All of those up here pass the test and gonna come and start at 80. Come at 80 and come across. And you read it down. Oh, that kind of too vertical. And you read it down like this. That looks more like 35, right? 35. What does that mean? It means that 80 persons scored less than 35 marks. 80 persons scored less than 35 marks. Right? This is 35 marks. So 80 persons scored less than 35 marks. So if you want to pass the test, you're going to have to score more than 35 marks. So if you put 35 marks or 36 marks, 60 will give it a marks just the same. I would just do 36 a while ago. 60 will give it a mark. It's an estimate anyway. All right. So So it's kind of, and then also the approach that you use depend on whether you're doing less than or if you're doing less than or equal to. But don't fret it. Don't fret it. Anyway, approach whether you use the 80 or the 81, 60 will give it the marks. It just depends on the wording. So after you find it, you want to say to yourself something like, okay, 80 students scored less than 35 marks. So you say to the examiner, if you want to pass the test, you need to score more than 35 marks. Because all the persons who failed scored less than 35 marks. So if you score 35 marks or more, you pass the test. Put it that way. All the persons who failed scored less than 35 marks. 80 persons who failed scored less than 35 marks. So if you want to pass the test, you have to score 35 marks or more. So this is actually the pass mark. So you can say this is the pass mark. This is a pass mark because the persons who failed scored less than 35 marks. The 80 persons who failed scored less than 35 marks. If you want to pass the test, you have to score 35 or more. All right? So that is it. So you can go to the 81 as well. You get 36. So you can say to the examiner, okay, you need to score 36 or more. But if you put the 35 or the 36, you know, they'll give it a mark just the same. But that's how you do it. All right, any questions? Any questions there?
No, sir.
All right.
No, sir.
So this class, we mentioned a lot of material today in this class, a lot of different things. A lot of small things, but plenty. A lot of things that are easy to understand, but still plenty. And so because it is so plentiful what we did today, I really and truly want you to go and watch the video over again. Watch the video over again. All right. And then now, in addition to that, I would want you to redo this question. Right? Use the same data and do all the things that we did with it. All right. And then on the handout, you have the handout. You can start trying some of these questions. I'm going to practice some more questions on Wednesday, and then I decide if I give you the classwork or not. But you want to be doing some of these questions now, guys. Right? Like maybe this one. I want to practice some of these questions, like this one. This is another one that you can do and draw a frequency Polygon. These questions and the homework number 2. This is one that we just did, right? Without actually looking at it, but we just do some work on that one. Use it to cover. We just use this data when I got to cover a number of things. All right, but you want to be practicing some of these questions. All right. So I think on Wednesday, it's another one that you can maybe do as well. Continues over to here. And that was in homework number 1. All right. So we're going to practice some more. So this is another topic we can start doing on the past papers now when we revise. All right. So Wednesday, I'll decide if I give the classwork on Wednesday or not. I'll decide. I'll based on the feedback from the class, how we're going, I'll decide if we do it on Wednesday or we practice some more Wednesday and do it on Sunday. I'm not certain if I think I should be able to have class on Saturday still. I'm planning to go to Gibson Relays on Saturday, but Gibson Relays starts at 1. So I might start class a little bit earlier on Saturday. But I'll tell you more about it as the week progresses, right? All right, guys. So that is it for today. Go and watch over the video.
Yes, sir.
All right. Pay attention to all the details. Do this particular question over. Come on, please. Just do it and do it. Use the same data and do all the things that I did with it to get the practice. Because once you can do it with one question, you can do it with all questions. And that's the beauty about the topic. You know, once you know what to do with one question, you will know what to do with all the questions. Just that the data will be different and the scenario that you're trying to paint will be different, but the approach will be the same. And the requirement more or less is the same. And the method is the same. All right, you just need to pay attention to the details that I mentioned today. Watch over the video, pay attention to the details. Look at when you use the boundary values when you use a midpoint and these things. All right. Look at all the details that I give. Look at how I brought the frequency polygon down onto the x-axis. Look at how I brought the cumulative frequency curve down onto the x-axis. Look at what the cumulative curve and the point on the x-axis, what it means. It means how many students got less than that mark, and it was 0, meaning that no student scored less than that mark. And they can ask that. They ask that in CSEC, guys. That's why I mentioned it today, because they ask those things. When the cumulative frequency curve comes down on x-axis, what does that point mean in relation to the data? All right, so pay attention to everything. Watch over the video. If you don't watch over any video before, this is the one that you need to watch over today. Because I did go and try to summarize everything and show you the difference in the method depending on the type of data that you have. And depending on the data presented, you need to look back at this part of it again. All right, because the method that you use depends on the data that you're given. All right, guys, so that's it for today.
Yes, sir.
Watch over the video for me, please. Don't come to class blank. Watch over the video. It's very easy. Watch over the video. That's the advantage of this online thing. You have a video that you can watch over again and again and again until you fully understand it. If you don't understand something still, you send me a message. I'll answer and explain it to you. I come to class with the questions. All right, guys. So do it for me, please. Do it.
All right.
Do it. Do it. All right, then. Bye, everybody. See you on Wednesday.
All right, bye, sir.
Bye-bye.